get stuck into it. Okay. I need to let you guys know what binary is. Binary is a numerical number system which represents any, in this case, decimal number in two numerals only. So binary is only ever written in ones and zeros. Okay? Whenever you see something like this, just remember, the first thing that should come to mind is it should be a binary, okay? What you guys should know about binary is always in base 2. So if it was 2 to the power of 3 times by 2 to the power of 4 would equal to, now because in laws of indices, if the base, this is the base by the way guys, if the base is the same in both cases, the base stays the same for the answer, but the indices you add them together. So that's 2 to the power of 7. So over here, our base is the same and our power would keep changing. The same as binary, our power will keep changing, starting from 0, adding 1 each time up to whatever you want, depending on how big the number is. Okay? So binary base 2, binary base 2, binary only ever written in ones and zeros, binary only ever written in ones and zeros. Okay guys? I don't know why I do a lot of repeating. It helps me. What about you guys? I'm going to be giving an example. How to convert from a decimal to a binary. Now, all we need to remember is we always divide the decimal by 2 until we get to 0. And our binary answer depends on the remainders of the decimal. If we start off with a 16, this is our remainders column. If we start off with a 16, 16 divided by 2, let's make that a bit smaller. 16 divided by 2 would give you 8. No remainders, so we put in 0. 8 divided by 2 gives you 4. Once again, no remainders, 0. 4 divided by 2 gives you 2. Once again, no remainders. It's getting a bit boring now. 2 divided by 2 is equal to 1. No remainders. Wait. The last bit. 1 divided by 2 would give you 0.5. Now, our remainder is 0.5. Our remainder could either be rounded up to 1 or rounded down to 0. What does this already look like? It already looks like a binary expression, doesn't it? Yeah, so we put a 1 here. We've dealt with our 0.5, so we don't need that in there anymore. Our answer for our binary, we always read from bottom to top. If I say read me over here, you guys will remember we always read from bottom to top. The answer is 1, 0, 0, 0, 0. Now, that's not the end of it, guys. I'm so sorry. The binary expression can only be written as a multiple of 4s. So over here, how many numbers can you see? There are 1, 2, 3, 4, 5. 5. What's the closest next multiple of 4? We can't go down. We can't take any of these numbers out. Our closest next multiple to 5 is 8. So what we do is we have to add 3 zeros to the beginning over here, to the beginning of what we have found out. So we have 1, 2, 3. Guys, this is our answer. Let me just give you time to digest. So let me quickly explain that again. I have 1, 0, 0, 0, 0. How many numbers do we have over here? We have 1, 2, 3, 4, 5. 5. We can't take anything out, so we can't bear in mind that binary can be written as 4s or 8s. What we want is, we want it to look like this. We want it to have an 8. We want it to have 8 digits. 1, 2, 3, 4, 5, 6, 7, 8. but this only has 5. What do you think we should do? We can always add whatever amount of zeros we need to get to a multiple of 4. Do you get it? So in this case, we're going to be adding 3 zeros, and this is our answer. Now, to double check whether we've got this right, we can do the inverse. So in this example, we've learned how to convert a decimal to a binary. In our next example, we're going to learn how to convert a binary to a decimal. Let me just rewrite this. That's 1, 2, 3, 4, 5, 6, 7, 8. That's 4, isn't it? No, that's fine. Okay. So, like I said, remember when I said base 2? Yeah? Okay. Over here, this will be equal to 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 6, and 7. Yep. Anything to the power of 1 is 0, anything to the power of 0 is 1, 2, 4, 8, 16, 32, 64, 128. Now what this shows is there is no lots of 128. There is no lots of 64. We don't need this anymore, guys. There is no lots of 32. There is 1 lots of 16. And there is no lots of 8, no lots of 4, no lots of 2, and no lots of 1. What does that equal to, guys? 16. And don't you remember? Isn't this what we started with? Isn't this our decimal number? It is! This is how you convert a decimal to a binary, and then a binary back to a decimal. Thanks guys, thanks for watching. I hope you enjoyed it. I'll see you next time. See ya!